Hello, Professor. It's your two favorite students back at it again with another coding assignment. So here, we set both of the enemy x and y values equal to the random dot choice obtained in the empty cells array. Just like in our previous coding assignment, we decided to put both the x and y values into a paired coordinate, called enemy 1 position and enemy 2 position. Our enemy move function accepts 6 parameters. The current position of the enemy and player, the speed of the enemy, the entire grid, the grid size, and the square num. The goal is for us to determine which direction, up, down, left, or right, will result in the least distance between the enemy and the player.
So the way that we determine which distance, up, down, left, or right, will result in the least amount of distance between the enemy and the player is that first, we create 4 variables: new position up, new position down, left, and right. We're going to set it equal to the current position, x and y, but we're just going to offset it by the speed. So for up, we're going to minus the speed in the y direction. For down, we're going to add the speed for it to go down in the y direction. And the same thing for left and right. It's just going to be done on the x coordinate instead of the y. So once we obtain the new hypothetical position of the enemy, if it were to move in these 4 directions, we can determine which of the moves will result in the least amount of distance between the player and the enemy. So first, we're going to use the formula that you provided us in the coding assignment, the Pythagorean theorem, to determine what the hypotenuse would be if you just draw a triangle. So distance up, we're going to set equal to the square root of the y minus the player y squared, which is what this is, and then the x minus the player x squared, which is what this is right here. So we're choosing the Pythagorean theorem, and we're going to calculate the distance for if it were to move up, down, left, and right. So now that we have these 4 distances for the 4 directions it can move, we're just going to compare the distances to every other distance to find out which is the lowest. So while there might be a more efficient or eloquent way to do this, we're just using 4 if statements and then comparing each direction to every other direction. So for example, if the distance, if it were to move up, is less than or equal to the distance if it were to move down, and is less than or equal to the distance if it were to move left, and less than or equal to the distance if it were to move right, then we're going to call the code inside here. And then the same process for down, left, and right. We're just going to be comparing it to the 3 directions that were not used previously. So if it's the case that the distance, if it were to move up, is the least compared to the other 3 distances, then we're going to call the isValidMove function. This is actually the same exact function that we created in the previous coding assignment. So we're just going to call this, before we return it, we want to call it just to make sure that the enemy is not going to move on top of a barrier or intersect with any object on the screen. So we're going to call isValidMove and return the new position, and that's going to occur depending on which direction is closest. So that's how the enemy move function works. We're going to return the coordinates, and then down here is where we call the enemy move function. So we're just setting the coordinate of the enemy 1 equal to enemy move, and then we're providing it with the enemy 1 position. The speed that we provided and we ended up going with is 2. Anything higher than 2 usually results in the enemies being way too quick to even play. So 2 is the number that we decided on, and we're just going to do that for both the enemy position, enemy 1 position, and enemy 2 position. So now we're just going to talk about the files and images.
So as you see, we set the image path using pygame.load. Then the line below it, we scale the image down. And we do that for each player, enemy, and barrier. We then draw the images to the screen using displaysurf.blitz.
So displaysurf.blitz will be called for the player, both enemies. For the barrier, since we have a specific function to draw the barriers, we're going to do that up here. The draw barrier function. If it ends up having a barrier, if it's 1, for example, after we loop through the set or the list, then we're going to do the same exact method, displaysurf.blitz, and we're just going to provide the barrier.image instead. So we're just going to show the program functioning.
So, as you see, the character that you play is a piece of paper. Is a piece of paper in a bottle, and your enemy is Plankton, and he's trying to obtain the recipe to the Krabby Patty formula. And the berries, as you see, are tables from the Krusty Krab. So I don't know if you've ever seen SpongeBob, but they're from SpongeBob. Thank you.
Thank you.